Hey everybody, we're starting section 3.6, area, volume, and average value. So here we go. Let me switch projectors here so we could. Okay, I'm switching cameras and we're gonna start right now. Let me change unblur. Have you don't blur? Let me unblur it. Pow. Okay, here we go. So here we have two. Now we already learned how to find the area, under a curve, but going all the way down to the x-axis. But what I want to do today is to find the area. Let me get this. I want to find this area that's trapped in between these two curves. So I'm not going. So I'm not going all the way down to the x-axis, which is what I learned before. I'm finding the area in between these two curves. Well, what I'm going to do, I'm gonna break this picture up. This is, if you think about it, here's the top curve, and here is the bottom curve. I'll use purple again. So if you think about it, if I take this entire area that's under the black, the entire area going all the way down to the bottom, and I subtract the part that's under the purple. So basically, I take this entire piece here, cut away that lower piece down there. I'm left with this section that's in between the two curves. I'm left with that middle section that's in between the two curves, and that's exactly what I'm going to do. So I'm looking at the area under this curve, subtracting the area under that curve, and I'm left with this middle piece. So in other words, I want to find the integral. I want to find the integral. So let's call the first curve f of x, and the second, the lower curve, we'll call g of x. And I want to find the integral from a to b of f of x dx minus the integral from a to b of g of x dx. So in other words, I take this total area here, that's the integral of f of x, and this total area down there is the integral of g of x. And when I subtract it, I get this middle piece right here. Now, of course, we learned from laws of integrals, we could just take this and put it into one happy little integral. We could do it this way. The integral from a to b of f of x minus g of x dx. And I could write it that way. So whether you write it as two separate integrals or write it as one big integral, either way, it's the same thing. Comes out, it's the same thing. So let's do an example. That'll help a lot. So let's say we want to find the area that's between these two curves. In other words, if you notice, here's a parabola, y equals x squared, and here I have a straight line, y equals 6 minus x. If you notice, in this case, the purple one is on top, and I want to find the area that's inside this sort of a cup-shaped area. By the way, this is I did a horrible job drawing it, and but the first thing I need to know, I'm going to take an integral. Well, I'm going to take the purple integral minus the black, the black integral. But I got to find out the integral from where to where. I mean, like, what is that point right there, and what is that point right there? So first, I got to do a little bit of algebra, and I want to find the point where these two curves intersect. Well, to do that, obviously they're the same y value at that point, so I want to find the x values where they intersect. So I'm going to set, since y is equal to x squared and y is also equal to 6 minus x, I'm going to set these two things equal to each other. 6 minus x equals x squared. Now this becomes x squared plus x minus 6 equals 0. And this can be factored into x plus 3, x minus 2 equals 0. And that tells you that x equals negative 3 or x equals positive 2, which means that point right there is positive 2. And that point right there is negative 3. Now, of course, it doesn't look that way. The way I drew the picture, the 2 is a lot bigger than the 3. But again, you can't just go by a picture. You have to, crunch the numbers. Anyway, we want the integral. from -3 to +2 of 6 minus x minus x squared. Well, I have all these parentheses here. I actually did not even need the inner parentheses. I'm just saying. Anyway, this is going to be equal to the integral of 6 is 6x. The integral of negative x is negative x squared over 2. And the integral of negative x squared is negative x cubed over 3. And this is all being evaluated between 2 and -3. I'll let you guys crunch out the numbers and tell me what you get. So it's going to be, first we plug in the 2. 6 times 2 minus 2 squared over 2 minus 2 cubed over 3. And then minus, plugging in the 3, 6 times -3 minus -3 squared over 2 minus -3 to the third over 3. So we're subtracting that whole thing because that's the rule for integrals. And then when you crunch all that out, you get 19 and 11 30-seconds. Oops, I didn't read my own handwriting. I'm sorry. I'm looking at my notes. It's 20 and 5/6. There you go. I wrote down the wrong thing. Sorry about that. 20 and 5/6. And that's how we do that. Let's do another one. Here's an interesting example. This is actually from our textbook. Find the area bounded between the graphs f of x equals x and g of x equals 3 for x between 1 and 4. So here's x is 1, here's 4. Now we want the area that's in between these two graphs, so it's going to be this yellow shaded area. And I want to do this. This is going to involve a little bit of tweaking. And let's switch. I want to switch to just pencil and paper so you can see what I'm doing here. So let me just. So we have the red line is y equals 3. The slanted line there is y equals x. Now here's the thing. Remember we said you do the bottom minus the top, but which is the bottom, which is the top? Because here the red is on top and here the red is on the bottom. So what we're gonna have to do, we're gonna have to break this up into two separate integrals, and it's gonna go like this. We're gonna go the integral from 1 to 3 of the red minus the black, so it's of 3 minus x, plus the integral from 3 to 4, because I have to do the rest of it, and there is x minus 3. And now I'm going to combine these two separate integrals, and I'm going to get my answer. So here I have 3x minus x squared from 1 to 3, and here I have x squared over 2 minus 3x from 3 to 4, because these here are the antiderivatives of what I have inside the integral. Now it's just a bunch of substituting. This all equals . So basically, I plugged in a 3 here or 1 there. That was for the first integral, and here I plugged in a 4 to this one and a 3 to that one. That was for the second integral. And now I just got to do some plugging away, as they say. First, I have to change that. First, I got to change that 2 into a 3. Okay, let's. Well, notice, by the way, the 3 times 3 and the. I'm sorry, it doesn't cancel. My bad. It does not cancel. I thought it was gonna cancel. I realized it wrong. Let me get rid of all these parentheses. So I just did some simple multiplying. Now I just got to combine all this stuff together. I have a bunch of pluses, a bunch of minuses. Let's just get this stuff all together, and that is going to be. Let me start with the whole numbers. 9 minus 6. 14. What's against 2 is 18 plus 18 plus 8 is 26. 26 minus 3 is 23. 23 minus 9 is minus 1 is minus 8. Lucky 7. There you go. And that means that the area between these two curves is 7. Hey, before I go on, I have to make a little correction. That's 9 half, negative 9 halves, negative 9 halves is negative 18 halves, plus 1 half is negative 17. So this 8 should really be let me just read this whole thing. This should be 11 minus 17 halves, which is equal to 5 halves. And that's my final answer. 5/2. And by the way, that makes a lot of sense because this over here, let me go to purple. This is a right triangle where that's 2 and that's 2. That's 1 and that's 1. I have these two sort of right triangles. The area of the first triangle is 1/2 base times height. So it's 2 squared over 2. The area of the second triangle is 1/2 base times height. So it's 1 times 1 over 2. And that's 4. That winds up being 4 halves plus 1/2. It's 5 halves. So from simple geometry, you could see that the area is 5 halves. From this complicated calculus, we got the same answer, 1/2, now 5 halves. Now you may say, if I could do it with if we have simple geometry is good, why do I need this crazy calculus? Well, the reason is because you might get more crazy shapes, parabolas, and all kinds of crazy curves that I can't really do with just geometry. All different logarithmic curves, all kinds of stuff like that. I can't just do it. I don't have high school geometry formulas for that. So that's why the calculus saves the day.